right, one more, it's a little tutorial on one example of how to apply quadratic functions. Here's an example of a problem that you might see in a lot of different textbooks or in a lot of different problems. Parabolas are the equation for motion of projectile objects. So when you have a projectile going up, all right, it will come back down, all right, and what it creates is a, all right, parabola, okay, which is y equals x squared, or in some sort of form. Now, here what we have is an example of a diver. Okay, so it's a little diver that is given by this equation. So a path of the diver when he jumps off a platform that is given by this. Whenever you read through a problem, I like to identify key concepts. Obviously, the equation is important because it's the path of the diver, where y is the height in meters and x is the horizontal distance, all right, from the end of the diving board. So also I like to draw out sometimes a little drawing. So we have this little diver right there. She is fine. She's about to dive. All right, she's a little happy. And she's going to have some sort of path. The path of this, all right, is going to be this parabola. Now, this parabola looks a little bit complex, so I'm going to bring out the old calculator to help us out for this one. All right, and we're going to graph this. Okay, so I already have a parabola up here, but I'll clear that. And we're going to put in negative 4 divided by 9, and then we're going to take this to the power. We're going to take that. We're going to take 24 divided by 9 as well. We'll have x, and then we'll have plus 12. All right. Now, when we first do this, if you go to zoom 6 and you graph it, we probably want to figure this out and look at the domain and change the window if we need to. And it looks like we do. We need to change the window a little bit. All right, so let's think about this. All right, we want to figure out what the maximum height is. Well, our window is, well, obviously x being the horizontal distance from the platform, so we're not going to be any farther than 0. So we're going to make our x min 0. It appears that our one value is no more than 10 meters away when I looked at my initial step. And I can look over here again, right there, and we can see that in our 10 by 10 window, here was our value right there, which is okay. So we'll just say that our 0 can go from 0 to 10. Now, we have to get a little bit higher because, once again, if you look at it, we don't see our vertex. So I'm going to make this vertex a little higher. Let's go to, she's not going to go into the water, so we'll only go like negative 2 meters deep. And we'll go a little higher. Let's go 20. And we'll go by 2s. And we'll have our scale, and we'll graph that. See how this is? So this is the path of our diver, going like so. All right. So that is, so I'm going to bring this over here to my drawing and take this, move it, or flip this back, the back right there. And so if you can kind of think about this, this is where the diver is going to be. All right, so this person is going to be diving from this platform right here, and it's going to take this leap of faith and travel in this parabolic motion down into the water. And here's the water. And if you want to put sharks and other things like that in there, right, she's diving in a swimming pool, and obviously, let's say this is a dolphin instead. It's a little blowhole. Yeah, there you go. All right, so I like to have a little fun when I'm doing these. All right, now, the first thing is, how high is a diver when she leaves the diving board? Well, when she leaves the diving board, we're talking about her initial position. So to figure out this initial position, we are trying to figure out what is her height. Well, her height is the y value. So what is her y value when she leaves the diving board? Well, when she leaves the diving board, we're trying to look for the 0, when x equals 0. So actually, we're looking for the y-intercept of this graph. So to do this, we're going to just simply plug in 0 in for y into our original equation. When we have that, we get y equals 12. So that means her answer is that when she leaves the diving board, how high she'll be? She'll be 12 meters high. That's our first question. The next question we want to ask ourselves is that we want to find the maximum height of the diver. Now, the maximum height is going to be about right there when she dives in. Okay? Now, the maximum height is also known, when we talk about parabolas, is going to be the vertex. Well, in all of our other tutorials, we can do this by hand. All right, to find that maximum height, we're looking for that y value. We have a lot of weird fractions right here, so I don't know if that's the coolest thing to do. So make it a little bit easier for ourselves, all right, because I like to have the easiest thing. We can use our calculator. And we're going to punch this in. We're going to look for the max. So I'm going to go second calculate, or second trace, and we're going to find this maximum value. And I went a little too far. Apologize for that. Or you can just press 4, and we got our maximum. So we want to go to the left side of our maximum. All right, so create our bounds, and here it goes. So I got my left side right here. Press enter, and so now we're going to right side, about right there. Press enter, enter again, and we find our maximum is right here. So I guess it wouldn't have been that bad. All right, we get a value of 316. Okay, so when x equals 3, all right, we get a y value of 16. All right, so we have that. So what are we looking for? What is the maximum height? Well, once again, the height is, all right, the y value. So we are looking at this value. So we have y equals 16 meters. Okay. All right, so finally, we come to our last portion. How far from the end of the diving board does the diver hit the surface of the water? Now, looking at our one graph, all right, we have right here. So how far from the end of the diving board? So we're looking for this right here. Okay, so the end of the diving board. So we're looking for a horizontal distance in the diving board. How far? So the horizontal distance is she from the surface of the water when she hits the surface of the water. So we're basically looking for a 0. This is asking us to find the x-intercept. Okay, well, we'll try this. Maybe this works out, maybe it doesn't. We can go to our calculator again, and we will. All right, but I'm going to try to do this since the vertex was so easy in the last one. I want to see if this one will be as easy as well. So we're going to take this, and we'll set this equal to 0. And we'll take -4 ninths x squared plus 24 ninths x plus 12, and we have this. All right, and then from here, we're going to do some multiplying and whatnot. I'm going to multiply everything by 9. All right, so I'm going to multiply both sides by 9, just get rid of that fraction. When we have right here, we have 0, and we have -4 x squared plus 24x, and then we have 9 right here, and that should be 108. Okay, and now from here, we're going to factor out some values. All right, when we factor this out, we can factor out a -4, so I'm going to factor out a -4. I have x squared. This right here is going to turn into 6x. Oops, -6x. 6x. And then we factor out a 4 here. And if you realize this, we had our 3, so it's going to be negative. And this should be 3 left over, so we'll have 27. Factor it out. Okay. So from this point, we want to find the zeros, and we'll see if this is factorable. All right, we have 27. We're trying to figure out this value. Can we get 6? We have -4. We have x. I think it would work out. We have +3, and we have x minus 9, which looks to be like that. Does that equal 27? The middle is going to equal 6, equals 0. So we have x equaling -3 and 9. Obviously, looking at our little graph, okay, right here, we are not using the negative because it's not in our domain. So really, the answer is 9, x equaling 9. That meters away, she will travel 9 meters away when she falls in the water. We can also do this on our calculator, all right, just to show you real quick. We want to find our 0, and we could actually look on this graph and see it pretty well, but we'll go second calculate. We'll find the 0. All right, press number 2 for a 0. And it's going to ask us for a right bound, so we'll go over here, a little closer. It'll seem a lot faster by doing it another way. A little closer. It appears my calculator is all screwed up. All right, let's try this again. Second calculate. We'll find our 0, 2. All right, we're going to go our left bound. There we go. Okay, I screwed up. Next time I press it again. We'll go to our right bound. Right about here. Press enter, enter. And we get 9, 0. There we go. All right, so you can see that is at 9, 0. And so we verified our answer. So this is an example of how we can solve various problems of using our calculator, and how quadratics and what it means when we use the y-intercept, when we use a vertex, which is a max or min, and the x-intercept when things hit the ground or the surface, which is our horizontal axis. Hope this helps, and have a blessed day.